All right. So up to this point, we've been looking at being able to query the database, right? Retrieve data from the data. Let's look at being able to insert or update a database by being able to introduce data or modify data that is already there. So basically, the operations that we're going to be considering can mostly be described as being the CRUD operations, right? Being able to create, update, delete, create, read, update, and delete, right? The CRUD operations. So SQL updates include the 3 out of those 4, right? And being able to create, being able to update, being able to delete are all considered updates. Whereas read operations, all the select statements, they all fall into that umbrella of selecting. SQL allows you to insert a single record or insert multiple records in bulk, or delete records, or modify records that meet a criteria. So here's some of the syntax of the of SQL, right? Being able to insert a particular table, and then the values. There's two syntheses. One of them is if you provide only the values, then it will assume that you're giving them in a particular order, right? In the order in which you had created the table. When you created the table, you provided the fields of that table, right? The first name, last name, username, password. Right? If you had followed that particular order, then you can provide the values in the same order in which you had created the fields. It will assume those are the fields, and they have to be providing the correct data type. Otherwise, if you just want to insert just a few fields, or you want to specify them in a particular order, you can choose the. You can also provide the names of the original fields. So here's an example where we have already 3 records in there, but we're inserting a 4th record here, Boone, that it's listed and clipped at the bottom. Why are you clipped? You don't have to specify all the fields. If the fields are not required, you can just skip over them. For instance, here, presumably address and city were not required, right? That they can have null values in there. So we are just inserting 3 of the 5 fields in here. So here, when you provide the name of the columns, you have to make sure that you then provide them in the correct order, the values, and they map 1 to 1, right? Where you have field value, field value, field value, field value in the correct data type. If you don't provide the value, then you get the default value, right? The default value is just null if it's allowed. Otherwise, you can actually provide whatever default value you want and you stated it in the create statement. You can also use that is querying some other table and build the input to the insert, right? So for instance, a select statement can draw values from multiple tables, right? Build a virtual subset of that data, and that can be fed into the insert into a table, and you provide the column names, right? The column names have to match. Okay? Here's an example where we are creating an alumni table, right? That has fields SID, SName, major, and graduation year with data types integer, variable, char, so strings, two strings, and an integer for the graduation year. And here we are extracting from the student and the department. We're joining them in such a way that we're extracting the graduation year, and we're feeding that into an alumni. So basically a table that perhaps was empty, right? But we had all this information already in student names and department names, and we're extracting those that graduated, have already graduated, right? we can calculate and extract it and fill in an alumni. Someone might say that this is redundant data. Since you can find the same exact information in another table, why would you have a different table with the same information? So again, whether it's a good idea or not, that's another issue. Here we are inserting. We're using a select statement to retrieve, to modify. Actually, add a brand new column, S name, and extract the information for a particular student, and inserting it into a different student. But inserting a new student with the same major and graduation year as student 1. Oh, okay, so this is kind of like a copy, right? We might have a template that we can then use to copy and populate additional records. Delete allows you, just like insert allows you to add data, delete allows you to remove data. You can either say delete from a table or delete star from a table. They're equivalent. But you need to be careful, right? If you don't provide a where clause, it's interpreted as in remove everything, meaning remove. Since I'm not providing a where clause, it means all records, right? I'm not filtering. It means that I am by default assuming I am referring to all the records in the table and they're gone. Otherwise, we can typically databases will have a guard against this, right? And we'll say, careful, you're doing a delete on, and you're not providing a unique identifier field to do a delete, and you would have to explicitly tell it, it's okay, I know what I'm doing, right? Here we are saying, just deletes those fields that meet a particular criteria, and then those records are removed. So here we are removing from the persons table someone whose last name is Norton and first name is Edward, and then that's the last record number 5, and then it's no longer in the resulting data set. So here we are looking up to see if there are any sections that don't have any enrollments. Right, so we're looking for a select statement that retrieves all the section IDs from an enrollment table, so this would return all the So the inner select statement is selecting all the section IDs, right, that are in the enrollment table, but there are probably more sections that are not in the enrollment table, right? So the section table might have, maybe 10% of those sections don't appear in the enrollment table. So we want to know those, right? So we can use a not in operator. We say, okay, well, from the section table, return to me all the section IDs, right? And compare them all against the collection of all the sections in the enrollment table. The ones that don't match, right? That gives me a subset of those records that don't match in the inner select statement. And I want to remove those, right? Those sections are gone. Nobody enrolled for those sections, so we're closing those sections. Right, so we looked at insert, we looked at delete, and finally we have update. And as the name suggests, right, it allows you to refer to existing records and modify them, right? You can use the where clause to identify exactly which record you want to update, and then you can provide setters that provide new values for a particular column. Again, if you don't provide a where clause, right, you're basically saying I want to update all the records, right, irrespective of any criteria. So careful. Yes?
If you don't provide some columns, will it set those to the default value or keep them the same as they were before?
No, we'll leave them the way they were.
Okay.
Yep. It will run through the same constraints, right? So so presumably insert might have already taken care of inserting data that required data, right? So presumably it wouldn't let you insert something. But if you are updating it to something that was not valid, it'll run through the same constraints. So here it is. We have a Norton Edward. It didn't have Norton Edward didn't have an address in a city. He was homeless. So here we're giving him a place to live in Lowell, in Groton Road, Lowell. So we're sending the address and the city for Norton Edward. Yeah, so here we have inadvertently omitted the where clause, and now everybody lives with Norton. Right, they all live in the same address. Okay, so careful there. Here we are. Somebody is graduating, or they changed majors from chemistry to mechanical engineering, and now they have just moved the graduation year one more year. So we can refer to fields to the current value of the record, right? We can refer to it in the updates, right? So this will be whatever graduation was 2017 now becomes 2018, right? Which is pretty cool. All right. Okay, let's move on.